This is the Unit Math 8, Unit 6 Study Guide review. First problem. Look at the triangles below. Which statements are true? Choose that all that are correct. Well, we have triangle ABC has a measure here of 27 degrees, 45 degrees. And we have triangle QRP, and it has a 27 degree angle and a 45 degree angle. First, we need to know that the triangle ABC, the interior angles sum to 180 degrees. So we have 45 degrees plus 27 degrees, that's going to be 2, carry the 1, 72 degrees, and then they have to sum 180 degrees minus 72 degrees. The third angle, angle C, is going to equal 108 degrees. Now I'm going to check if that sounds right. And I look at this angle here at C, and it's obtuse. It's more than 90 degrees, so 108 degrees makes sense. So if these two angles of A and B are the same as Q and P, then the third angle, because all triangles add up to 180, so this angle I can tell, angle R, is equal to 108 degrees. Also. So let's look at these statements. Now, these are not the same size. The angles, to be congruent, all three sides have to be the same length. And the three angles have to be the same measure. Well, we know that that's a check, but not this one. That's not true. So instead of it being congruent, they're not congruent. Instead, we're going to say that they are similar triangles. And similar triangles have just the squiggle line. And when you have similar triangles, they have their ratios are the same. So a dilation factor. So if we look at here, the sides are 20 to 10. So 2 to 1 difference here. Since they are similar, this has a ratio of 2 to 1. So whatever X is, T is going to be half that. And whatever Y is, S is going to be half of that. And we have a ratio set up here, 2 over 1 equals Y over T. And so we have 20 is to 10. Well, 20 and 10, they are reduced. They both have a factor of 10. They reduce to 2 to 1, so that's okay. So when I look over here, 2 to 1. Now I'm going to go make sure that they're corresponding. AB goes to QP. Okay, I look at that. A to B. It goes 1 mark to 2 marks. That's good. P to Q would be the same direction. So if I keep that, I can look at B to C should be the same as Q to R. Well, that's Y in the numerator to T. And if I go over here, Y to T, that's true. So I'm going to put a check mark there. Now I go to the second one. Measure of angle R is equal to the measure of angle C. Okay, well, we did that math. Let's track over here. Measure of angle R we proved was 108. The measure of angle C was 108. So that's true also. They're both 108 degrees. Now let's look at this ratio. Now the other way around, 1 to 2. So they're comparing the small triangle to the large triangle. Here's the small triangle to the large triangle. So we need to do the same thing. The small triangle then would have to be compared to the large triangle in the same direction. But that's not what's happening. This is, the X is in the large triangle. So, and this is the small triangle. So that is not true. Does S equal X? Well, they're not congruent triangles, and they're two different triangles, so that doesn't make any sense. They're not congruent, so they're not the same size, so that doesn't make any sense. Now we have triangle QRP, similar to triangle ACB. Let's make sure that we have in the right direction Q, R, P. Okay, so we went to the second marked angle to the third marked angle to the first. So if we go to the second marked angle to the third, it should be A, C, B. Well, they are, we're going to check it. We already proved that they are similar triangles. Problem 2. The Madera City Marina is building a new dock at the Fresno River for accessing the slips that boat owners use for docking their boats. Okay, so it says here we're building a new dock at the Fresno River. So here's the dock. The slips can be represented by parallel lines. Parallel lines. Here's line 1. Let's call them line 1 and line 2. And this line crosses them. We're going to call that T for transversal. You could call it L sub T if you want. Well, if we want to make it LT like that. With the dock cutting across the lines to form slips on either side of the dock. A sketch of the design is shown below. The builder needs to know the measures of the angles on the sketch to begin designing support brackets that will connect the new dock to the slips. Which statements are true? Select all that apply. And here the print's a little dark. Angle, these are numbered 1, 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. The first statement, the measure of angle 2 and 8 have a sum of 180 degrees. Well, first, before we begin, these are parallel lines, so I'm going to mark them with a red line. This means that the lines are parallel. I'll do it in this direction. This line is parallel to this line. Okay, well, what do we know? These lines are always going in the same direction. And they're cut by a single line that's straight. So if I start marking these, which ones are congruent, I'm going to use a single mark to show which ones are congruent. 3, angle 3, and of course, angle 3 and angle 4 are not congruent, but they're going to make a straight line. Well, if angle 3 and 4 are going to make a straight line, and 2 and 4 are going to make a straight line, that means that angle 2 and angle 3 have to be exactly the same. Okay, and since this line is, this transversal line is cutting across, and since line 1 and 2 are parallel. That means this angle in the same corresponding position, angle 7, has to be the same as angle 3. Likewise, angle 2 and angle 6 have to be the same angle. Okay, well, these are the same angles, 2, 3, 6, and 7. Notice they all form a straight line. 1 and 2 form a straight line, so these two guys have to, angle 1 forms a straight line with 2. Well, 2 and 3 are the same. That means 4 also has to be the same. Okay. Same thing's true over here. 5 and 6 form a straight line, so this angle 5 has to be the same, and angle 8 has to be the same. So now we have them marked as to which angles are congruent. We can make a congruency statement. Angle 1 is congruent to angle 4, and that's congruent to angle 5, and that's congruent to angle 8. And the other ones are congruent too. Angle 2 is congruent to angle 3, is congruent to angle 6, is congruent to angle 7. Okay, so we have a lot of information. The measure of angle 2 and 8 have a sum of 180 degrees. Let's look at angle 2. We know that anytime you put one of these angles and you add them to one of these angles, it's going to equal 180 degrees. So we just need to see if angle 2 is in this category and angle 8 is in this category. Well, we know anytime you add them, anytime, anywhere, if you add these together, you're going to get 180 degrees. So that's true. We'll double check by looking, where's angle 2? Right here, angle 8. Well, if I was to slide angle 2 down to where angle 7 is, they're congruent, right? They form a straight line, and straight lines are 180 degrees. True. Angle 1 and 6 are congruent. Well, we've already marked them all and measured them. So let's go to angle 1. It's got 2 marks. Angle 6 has 1 mark. That's not good. So you can also tell angle 1 is obtuse. Angle 6 is acute. So that's a really bad answer. We want to X that one out. Angles 4 and 5 are vertical angles. Okay, a vertical angle is, we studied those. Vertical angles are congruent and they're in the opposite position. So we need to find 4 and 5. 1 and 4 are vertical. 2 and 3 are vertical. I don't see that. When I go over here, I find 5. 4 is over here. 5 is over here. That's not vertical position. In fact, if we label, if this is the interior, and then we can see that 4 and 5, yes, they're congruent, but they're on alternate sides of the line. We call them alternate interior angles, not vertical angles. So that's an X. And then we get down here, angles 5 and 7 are congruent. Let's look. Here's angle 5, it's obtuse. And here's angle 7, it's acute. Just from the eyeball test, we can tell that's false. The measures of angles 3 and 5 sum to 180 degrees. Well, we already made a nifty thing over here. So if we go, the measures of angle 3 and 5. Here's 5. Here's 3. What did we say? All these obtuse angles plus any of these acute angles, when you add one of each together, you get 180 degrees. So that's true. So we're going to check that. Problem 3. Which of these series of transformations will result in an image that is congruent to its pre-image? Choose all that are correct. Okay, well, let's see. Let's make, for each one, let's test it out. Here's a X and Y axis. And let's look at the first one. Rotation of 90 degrees, okay? That's from like 12 o'clock to 3 o'clock. And we're going about the origin. Now, if it's a positive rotation, it's going to rotate clockwise, followed by a translation of 2 along the x-axis. And let's go back to the original question. Which of these series of transformations will result in an image that is congruent to its pre-image? So it starts at the pre-image, and then it has an image. Okay? So let's say we had the letter L. And it's going to rotate 90 degrees, so it's going to rotate about the origin. Here's the origin. We're going to rotate it 90 degrees, 90 degrees, 90 degrees. We end up with something like this. And then it translates 2 along the x-axis, so it's going to translate everything this way, 2 units. And since it just rotated and it just translated, then it's okay, it's still congruent. So we're starting to think, oh, well, what creates things that are not congruent? One of there's translations, reflections, and rotations are just moving the object. We call these are just changing them, and we call them transformations. So we have these 3 transformations. There's a 4th transformation, though, and that's the dilation. So these 3 here, 1, 2, 3, they don't change the shape. So these 3 don't change the congruency. Dilations do. They create similar figures. That's this symbol. So what are we looking at here? A reflection over the x-axis followed by a reflection over the y-axis. Which of these will fit? That will be congruent still, because it didn't undergo a dilation. A rotation of 270 degrees counterclockwise and a dilation. Uh-oh, I saw that word. Dilation and a scale factor of 3. So that one will not be congruent. And then we have a translation of 5 along the x-axis followed by a translation of 10 along the y-axis. A translation of 5 and a translation of 10, that's okay. That'll still be a good figure.